So in this video, we are introducing quadratic functions. Now, quadratic functions all come in a particular form. This is like a general form, but you'll see a bunch of different ways we can represent a quadratic function. But basically, it's in the form of y equals ax squared plus bx plus c, where a, b, and c are numbers. Now, the main thing that sets a quadratic apart from other graphs is the fact that the highest power is this 2 here. So anytime you see something in the form of x squared and then something else on the other side where the powers are smaller than 2, this is going to be a quadratic. Now, these come in two different sort of orientations. One we have on this left-hand side. When you have a positive coefficient of x squared, your parabola will look like this. It will begin at the top, it will go down, and it essentially hits this part down here. We call this the vertex or the minimum turning point. We call it a turning point because it goes down and then the graph turns and comes back up. And in this case, it's a minimum because it's the lowest point on this graph. When the coefficient is negative, as we see here, we get a maximum turning point. So it comes up, turns at this maximum point, and then goes back down. Now, there are a few key features of this that we're going to discuss. Now, we talked about a couple of these ones here already. When we have y equals x squared, the vertex or the turning point is at the origin, 0, 0. That's true for both y equals x squared and y equals negative x squared. We have what's called an axis of symmetry at the y-axis. So if you look here, it looks like this part is mirror reflected on this side. Same with this. This part is mirror reflected. So we have what's called an axis of symmetry. And this occurs at the y-axis or at the line x equals 0. Now, both the x and y intercepts are 0 here in this sort of simple quadratic graph, y equals x squared. And when we have a negative, we reflect the graph around the x-axis. So here you can see the graph is above the x-axis here, and the negative flips it so it's below. This is shown by the negative numbers here as opposed to the positive ones here. Now it's below the x-axis. And we can change the coefficient, so the number in front of x squared, to affect the height and steepness of the parabola. That's what I'm going to show you here. So if we go onto Desmos, you can see I have a general quadratic graph here. This is, because c is 0 and x is 1, this is my y equals x squared graph. So it looks like this. And as I change this coefficient of x squared, as it gets larger, the graph gets quite steep, okay? So it affects the height of the graph. The bigger that coefficient gets, the steeper the graph gets. As we go smaller, it will get wider. Now, when we go into the negatives, my graph has now flipped. It's now reflected below the x-axis. So it looks like this. And the more negative we get, the steeper it gets in the negative direction. Now, if we go back to the original form up here, we can also change this value at the end. This is the constant. This is one of the main transformations I'm going to talk about. There are other ones, but most of them are outside of the sort of scope of this course. We're just going to be sketching basic parabolas here and basic quadratics. So if I change this value, it will shift my graph up and it will shift the graph down. So there's a bunch of ways we can transform this graph, which we will talk about when we actually start to sketch these. But we're basically going to be drawing them using the same table of values we've been doing before. And we will encounter a few different types of quadratics or parabolas. That's another name for them. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.